Greetings, M squared here, and we're going to continue our discussion on the standard form of a quadratic function. Remember, that's a quadratic trinomial. You see the quadratic term, the linear term, and the constant term. We're going to talk about how to use our pattern, our A pattern, or 135, in combination with this so that we can graph it. So it was really easy when we used vertex form because we could see the vertex. And then we could graph it using our pattern quite quickly. This is going to take a little longer because we first have to find the vertex. That's the first thing you have to do. So we have to find A, B, and C so that we can use our axis of symmetry formula, which was negative b over 2a, to then find our vertex. So the first thing we do is we look in front of the x squared to find our A, we look in front of the x to find our B, we look in front of, at the end to find our C. Remember, that's our y-intercept. C is the y-intercept. It opens down because it's negative. The quadratic coefficient is negative, and we know our y-intercept is negative 13. So let's find our axis of symmetry. So we say x equals the opposite of b, which was negative 12, over 2 times a, which is negative 2. Well, we know that if we have a negative right next to a negative, subtracting a negative is the same thing as adding a positive kind of thing. So that's positive 12, and this is negative 4, and 12 over 4 is 3, so x equals 3. So our axis of symmetry is 3. Why that's important is because that number, the axis of symmetry, is also the x-coordinate of our vertex, and that should have been negative, shouldn't it? Because we were dividing by a negative 4. So now we have to find our y-coordinate, and we do that by finding f of negative 3, or whatever that value of the x, that negative b over 2a was. So we're going to find f of negative 3 by plugging it back in there. So we're going to do negative 2 x squared minus 12 times x minus 13. You can do this on a calculator. You can do this on your own. Let me show you how to put it in the calculator, but if you want to do it on your own, you can do that too. You just have to remember your order of operations. The calculator will do that for you, but order of operations would be you square that, so you'd get 9, then times negative 2, then you'd get 36, then you'd say negative 9 plus 36 minus 13. But I'm going to show you how to do that all in your calculator, and if you can see it, yep, I think you can. So you're going to write it exactly like this, parentheses and everything. It's really important if you put it in your calculator that you put parentheses around this negative, because squaring a negative, if the parentheses aren't there, on most calculators that know the order of operation, you'll get the wrong answer. So make sure you always put parentheses around each of the x values, and then that saves you some trouble later. All right, it looks like 14. And again, you could have done that here, right? You could have gotten negative 18 plus 36 minus 13. All right. Let's see what we get here. I'm just checking real quick. Something seems wrong. Did I do something wrong? That does not seem like 14. I see what I did wrong. I forgot my 2 right there, my negative 2, so I'm going to insert a negative 2. It's really important that you have everything you need in there. All right, now we get 5. Was not 14. I thought that seemed a little strange. All right, checking your work is cool. Make mistakes, you fix your mistake. That's what we do. All right, we've got our vertex. So our domain is all real numbers. Our range is y is less than or equal to, because a was negative, less than or equal to this y value. And then because we're opening down, we know it's a maximum value. So that's just a little review of how to find all your A, B, C's and axis of symmetry and vertex. Now we're actually going to use that to graph. How exciting is this? We're first going to find our A, B, and C. We know that our y-intercept is 19, so we probably won't be graphing it because it's kind of up there. We know that it opens up because A is positive. Our axis of symmetry is x equals the opposite of 12, of negative 12, which is 12, the opposite of b, over 2a, which is 6. Giving you a little shortcut there. That's 2. That tells us that our vertex x-coordinate is 2. So now we have to find f of 2. We do that by plugging that in. 2 times 2 is 4. 4 times 3 is 12. 2 times 12 is negative 24. So now I'm at negative 12. Plus 19. So 19 minus 12, because this equals minus 12, is 7. So there's our vertex. Our domain is always all real numbers. Our range is y is greater than or equal to, because a is positive, it's greater than 7. And now we are going to, sorry, it opens up, so it's our minimum. I'm trying to answer the questions and graph at the same time. It's not working. So the first thing we do when we graph, now that we have the vertex, so now it's easy, right? It's just like what we did before with vertex form. We graph our y, our vertex. So over 2, up 7. We know what opens up. So we are going to go over 1. Remember our 1, 3, 5 pattern? So that's how it would be if a was 1, right? This is our, if a equals 1, it's 1, 3, 5. Remember though, a equals 3. So now I have to multiply each of those by 3. So instead of going over 1 and up 1 like I would do if a was 1, I go over 1, up 3. And this time I can't go any further because the graph runs out, and so that's all I graph. All right, let's try this one, and then you're on your own. So this part we've been practicing on. We've already graphed, so we're not going to spend too much time today. Most of it's review, and then you're going to be on your way working on your homework. So a equals 1/2, b equals 4, and c equals 13. We know it opens up because a is positive. We know the y-intercept is 13 because in standard form, c is the y-intercept. Our axis of symmetry is x equals the opposite of b over 2 times a, but 2 times 1/2 is 1. So we know it's just -4. That tells us that the x-coordinate of our vertex is -4, and now we have to find f of -4. When we put -4 back in here and square it, -4 squared is 16, and half of 16 is 8. Then we put -4 in here and we get -16 plus 13. Well, 8 minus 16, or you can do it this way too, that's sometimes easier. -16 plus 13 is 3. 3 plus 8 is -3, sorry. 8 minus 3 is 5. So our vertex is -4, 5. Our domain is always all real numbers because in a parabola, the sides go forever to the left and forever to the right, but they don't go forever up and down. That's why the range is limited, and it starts right here and goes up, and that starting place is this y value. So we say y is greater than or equal to 5. So we're going to graph our vertex, which is 1, 2, 3, 4, 5, and down 4, 1, 2, 3, 4, and then our a, remember our 1, 3, 5 pattern? 1, 3, 5. But now we have to multiply them by 1/2 each. So it's going to, and remember, it keeps going too. 1, 3, 5, 7, 9, that's our pattern. So over 1, up 1/2. Over 1 more, up 3/2. 1, 2, 3. Over 1 more, up 5/2. 2, 4, 5. And then over 1 more, up 7/2 if you want to keep going. 1, 2, 3, 4, 5, 6, 7. And we can use that axis of symmetry so that we know that what's happening on one side of the parabola is happening on the other side. And that's how we can graph that. Okay, so we reviewed all those pieces separately. Now we're putting them all together, so you should be fine. Good luck with that. M squared signing out.